Hello, everyone. This would have been our get together tomorrow on October 28th for the Providence SAT math class. Unfortunately, my wife just reminded me that we have a get together that we scheduled for the 28th. This was obviously before SAT math and is kind of an obligation that we need to fulfill. But the beauty of being in Zoom world is that I can record this class and I'm going to pace it a little bit differently. So I'm going to do this in three parts. I'm going to start this class. The first part is going to be word problems. Then the second part is going to go into the other areas, which are linear equations and then equations of a line, parts one and parts two. This way you can review each subject without having to listen through the entire lecture, because during the time we're actually meeting, I'm kind of pacing the class for more interaction. This is just going to be me lecturing to my laptop. And again, apologies, but let me go ahead and share my screen. Okay, you've seen this. The only thing that really changes is the date. I typically put my email address, but it's going to be on the next slide as well. And if you notice, our calendar arrow has changed. So tomorrow is going to be a YouTube day, and in about 2 weeks on November the 11th, which I've already talked about, that's going to be a YouTube day. And November the 4th, we're not going to have class because of A&T and GHO. But you see my email address right there lit up, rlgoodwin@aggies.ncat.edu. I'm very grateful that many of you have used this to contact me. You also have my mobile number, which I'm going to let it stay up for a little bit so you can take a picture of it, put it in your phone. You can either text me or email me if you have any questions on any of the videos that I'm going to record this evening. This is Dr. Kazmikia Corbett, and I'm probably mispronouncing her last name, Melare. She recently got married. She's the assistant professor of immunology and infectious diseases at Harvard. Dr. Corbett uses her vital immunology expertise to propel novel vaccine development for pandemic preparedness, including mRNA 1273, a leading vaccine against SARS-CoV-2. The vaccine concept incorporated in mRNA 1273 was designed by Dr. Corbett's NIH team, which stands for National Institutes of Health, from viral sequence and rapidly deployed to industry partner Moderna Incorporated for phase 1 clinical trial, which unprecedentedly began only 66 days from viral sequence release of mRNA 1273, which was shown to be 94.1% effective in phase 3 trial and authorized for use in multiple countries. Alongside mRNA 1273, Dr. Corbett boasts a patent portfolio, which also includes universal coronavirus and influenza vaccine concepts and novel therapeutic antibodies. In all, she has over 15 years of expertise and experience studying dengue virus, respiratory syncytial virus, influenza virus, and coronaviruses, garnering several prestigious awards such as the Benjamin Franklin Next Gen Award and the Salzman Memorial Award in virology. Combining her research goals with her knack for mentorship, Dr. Corbett invests much of her time in underserved communities as an advocate of STEM education and vaccine awareness. Why should this concern you? Because Dr. Corbett was born in a place called Hurdle Mills, North Carolina, and I looked it up on the internet. It's about an hour east of Greensboro, going through I-40. So you'll actually go through Orange County. And that's her Wikipedia information. She was raised in a large family of step siblings and foster siblings. And this is a gift that I got from the magazine Nature about the Delta variant. So we have Dr. Corbett to thank for, if you've taken, like I did, the Moderna vaccine. We have her to thank for that. And as I said, I'm going to go through word problems. This video will just be on the word problems, and then I'll go to the next video for linear equations. And then the next video will go through equations of a line, parts 1 and parts 2. And you'll be able to see this in the email that I send, that you can go to each one, look at them, and if you have any questions, you can email me. And unfortunately, because I will finish the word problems, I will send homework that I didn't send last week. And if I get to it, I'll send some problems for linear equations and equations of a line, parts 1 and parts 2. Okay. So I think that's all I have. Let me stop sharing, switch the camera. This you remember from last week. You can go look at the video from last week. I'm not going to read through all of this again, but notice I bolded, state in words what the unknown is. So what we're going to do is we're going to do something that I call table it. So in other words, I'm going to take what's said in the word problem, and on one side of a table, I'm going to put down what it is in the word problem. On the other side of the table, we're going to put it into an expression that's a mathematical expression, and then we're going to solve the word problem. And of course, like in step 4, we're going to say, does it make sense? And we don't have any units to worry about in step 5, so let's get to it. So I think we introduced this last week in both classes. Betty and her young sister Lynn work together to peel potatoes. Betty peels 15 more than twice the number of potatoes than Lynn peels. Together they peel 75 potatoes. How many potatoes does Lynn peel? And so this is something you're going to see over and over again, and I put it down in specific steps. But to solve this problem, we need to determine the elements of the equation. What is the variable? What goes on the right side of the equation? What goes on the left side of the equation? If you go through these 3 steps, you can figure out most word problems. So this is a kind of a short word problem. So here, what is the variable? Another word for variable is the unknown. So in other words, what's your x? So look at what the word problem says. Betty peels 15 more than twice the number of potatoes than Lynn peels. Now, what Lynn peels is our unknown. Betty peels 15 more than twice the number of what Lynn peels, and together they peel 75 potatoes. So this is x plus 2x plus 15 equals 75. Combine like terms. We subtract. Here, x is equal to 20. And we're going to do this over and over again. Even though the word problems are going to get a little more complex, we're going to do exactly the same thing. So let's go to problem number 8. Let's see what this says. Martin bought a laptop computer at a store that gave a 10% discount off the original price. The total amount he paid to the cashier was $715.50, including a 6% sales tax added to the discounted price. What are the original prices of the computer? So, what is the variable? Our unknown is the laptop's original price. Second part, the total amount Martin paid to the cashier is $715.90. This goes to the right of the equal sign. The discounted price of the computer is going to be whatever the original cost was minus 0.1. So another way of representing 10% is to represent it as a decimal. So if you divided 10% is considered 10 divided by 100. So if you divided 10 by 100, you would get 0.1. And then times X, which is the unknown, the sales tax adjustment of 0.1%. So let's do this. 10% discount off the original price. So we have that here. And then a 6% sales tax is added. And this has to be, even though it uses the word added, this has to be factored. So I'm going to use an asterisk to represent multiplication here, 1.06. And the total amount that Martin paid was $715.50. So now we have our equation, 1 minus 0.1 x times 1.06 equals $715.50. So 1 minus 0.1 is just going to be 0.9 times x times 1.06 equals the same thing. Point 0.9 times 1.06 is going to be finally 0.954 x equals the price that Martin paid. Now, x represents the original price. So now we have an algebraic equation, and all we have to do is divide by the coefficient. We know any number divided by itself is 1. Because this is such a weird number, on the SAT, they're probably going to let you use either one of their software calculators or a calculator that you bring in. X in this case is going to be $750. Remember, we're looking for the original price before the 10% discount, before you add the sales tax. So what you did is that you calculated backwards. And remember, one of the questions that we ask is, does this make sense? Well, if you're looking for the original price and it's a 10% discount, then the original price has to be more than what Martin paid. And this makes sense. On to the next problem. So if you notice, I keep drawing this table down here. The table is so that you can get used to when you see a word problem, put everything in words on the left side, put what you're looking for on the right side, and try to make it into an algebraic equation. So this one, number 9. Oliver is selling photographs as part of a project in his entrepreneurship class. He sells the first 20 photographs for $10 each. Because the first 20 photographs sold so quickly, he raised the price to $15 each for the rest of the project. After his expenses, Oliver netted a profit, of 80% of the revenues from his sales. How many photographs must he sell for the rest of the project to earn a profit of $400? And they give you 4 options here. So now we've got to really be accurate because we can't guess. So what is the variable? Well, step A, the variable is the number of additional photos that he must sell. Then the profit of $400 goes on the right side of the equal sign. The total revenue is times 80% goes on the left side of the equal sign. So let's break this down. We've drawn our table. You would do this with a pencil. He sells the first 20 photographs for $10 each. So that's going to be $20 multiplied times 10 equals $200. And that should be $10, not $20. Doesn't really matter, but I'm kind of anal that way. Because the first 20 photographs sold so quickly, he raised the price to $15 each for the rest of the project. So the rest of the project, he raised them $15 each. How many? We don't know. So the rest of the project is our X, the unknown. Oliver must net a profit of 80% of the revenues from his sale. So we're going to say here 200 plus 15x, and 80% is 0.80. That's going to be equal to 400. How many photographs must he sell for the rest of the project to earn a profit of $400? So if we, and I'll write it so that you can see this. So I'm going to take the 0.80 or 80%, 200 plus 15x equals 400. Now we're going to distribute that. So 0.80 times 200 is going to be 160. And then times 15, that is going 15x, that's going to be 12x equals 400. Then we're going to subtract 160 or 160 from both sides. That will leave us with 12x is equal to 240. We divide both sides by 12. X is equal to 20, or in this case, you would circle, color in option B on the SAT. You didn't have to guess. You just had to set it up. Number 10. Max is working on a farm in the summer as part of a crew. He earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Max saves 90% of his earnings each week. How many hours must Max work the rest of the week to save $270? Take a deep breath. We're going to get through it. Asking the same questions. We have 4 options. We do not have to guess. What is the variable? We say here the variable is the number of additional hours he must work. That is our unknown. The savings of $270 goes to the right side of the equal sign. The total earnings times 90% goes to the left side of the equal sign. So when I say note, I am drawing my table. So look what we have in quote and underline. He earned $8 per hour for the first 10 hours. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. So $8 per hour for the first 10 hours. And then he raised his salary $10 per hour for the rest of the week. The variable is the number of additional hours he must work. That variable is our identity unknown, our X. Max saves 90% of his earnings each week. So we can take 90%, we can convert that readily to 0.90. We can multiply it times our equation. So it's going to be $8 times 10. It's going to be 80 plus 10x equals $270. We distributed to 0.9. 0.9 times 80 is going to be 72 plus 0.9 times 10 is going to be 9x equals 270. Subtract 72 from both sides. That leaves me with 9x on this side. And that's going to be equal to 198. You can divide both sides by 9. And this I'm going to anticipate you do on a calculator because x is going to be equal to 22. And that is going to be your option B. In the final stretch for word problems, last word problem. Anybody a basketball enthusiast? You may want to learn this one. The mean score of 8 players in a basketball game was 14.5 points. If the highest individual score is removed, the mean score of the remaining 7 players is 12 points. What was the highest individual score? And you're given 4 options. So, once again, for the last time, what is the variable? This is the highest individual score. That is our X. The total number of points by the remaining 7 players goes on the right side of the equal sign. If the average is 12 points, then it's 7 times 12, which is 84. The total number of points by all 8 players goes on the left side of the equation. If the average is 14.5, then it's going to be 8 times 14.5, which is going to be 116. So that's going to give me, as you can see, the mean score of 8 players in a basketball game was 14.5 points. We've done that. If the highest individual score is removed, that is our unknown. The mean score of the remaining 7 players is 12 points. What is the highest individual score? So that is going to give me, we said 8 times 14.5 is 116. We are subtracting our unknown, and we're going to set that equal to the remaining players, which was 7 times 12, which is 84. And then we're going to subtract, because we got the X over here, we're going to subtract, surprisingly, 116 from both sides. That's going to leave us with minus X is equal to minus 32. And therefore, because minus X equal to minus 32, our unknown is 32 points. And that's going to be option C. And once again, you didn't have to guess. I'm recording this so that you can have it as a reference. Look it over. Call me if you have any questions on how we set it up. But I'm showing you how you can take any word problem, set it up in this table, take the words that are in the word problem and convert them into mathematics that you then use to come up with the answer, which of course, above all, has to make sense.